Welcome to MRL. In this learning session, we'll be learning the second part of simple equations, and in this part we'll be going through the different properties and applications of simple equations. Now, the first important point to be discussed is framing equations from a given solution. Now, if x is equal to 2 is a solution, if x is equal to 2 is a solution, then we have to frame equation. If x is equal to 2, then x is equal to 2, we can add 5 on both the sides. It becomes x plus 5 equal to 2 plus 5, or x plus 5 equal to 7 is an equation. It is a simple equation of when x is equal to 2. And so also we can divide both the sides by 2. X plus 5 by 2 is equal to 7 by 2 is another simple equation. And also we can multiply 3 on both the sides. X plus 5 by 2 into 3, 7 by 2 into 3 becomes x plus 5 into 3 by 2 is equal to 21 by 2, which is again another equation for the same solution x is equal to 2. Therefore, for a given solution we can form many equations. Remember that. Therefore, a polynomial equation in one variable has only one solution, but from one solution we can form many linear equations in one variable. Now, to check if the given value is a solution of the given equation. Now, here we have been given an equation that is 2x by 5 plus 3 by 5 is equal to minus 1 by 5. We have to check if x is equal to minus 2 is a solution of this given equation. And to do that, let us understand the procedure. 2 by 5x plus 3 by 5 is equal to minus 1 by 5. Now x is equal to minus 2. Put where x is there minus 2. Then 2 into minus 2 becomes minus 4 by 5 plus 3 by 5 equal to minus 1 by 5. Now the denominator is the same. Just add the minus 4 and 3. We get minus 4 plus 3 becomes minus 1 by 5 and minus 1 by 5. And that is minus 1 by 5 is equal to minus 1 by 5. LHS is equal to RHS, and therefore the value x is equal to minus 2 satisfies the equation or makes LHS equal to RHS, and therefore x is equal to minus 2 is the solution of the given equation. Remember that. Now, equations reducible to standard form. If you are given an equation and you are asked to solve, first of all we have to reduce this given equation into a standard form and then solve it to get the value of the x which satisfy the equation. Now let us understand with an example. Now in this example we have x plus 2 into 2x minus 3 minus 2x square plus 9 upon x minus 1 is equal to 3. Now this is not in a standard form, so first let us convert this into a standard form. For that, eliminate the denominator first. So multiply x minus 1 on both the sides. When I multiply x minus 1 on both the sides, this x minus 1 gets cancelled and 3 gets multiplied with x minus 1. So we have here in LHS x plus 2 to x minus 3 minus 2x square plus 9 and 3 in the bracket x minus 1. Now open the bracket. As you know, we have to multiply these two first. That is x into 2x is 2x square, x then we have 2x into x is 2x square, and then we have 4x. 2 into 2 is 4x, and minus 3 into x is minus 3x, minus into plus is minus 3 into 2 is 6, then minus 2x square as it is, 9 as it is, 3 into x is 3x and minus 3. So simply multiply and open it, or multiply the brackets by applying distributive property and open it. Now simplify it. 2x square cancels here. 4x minus 3x minus 6 plus 9 is equal to 3x minus 3. Now you find that 4x minus 3x is x, minus 6 plus 9 becomes plus 3 is equal to 3x minus 3. Now bring 3x to the left, it becomes minus 3x plus x plus 3 minus 3 plus 3 minus 3 becomes plus 3. So therefore minus 3x plus x is 2x, plus 3 is plus 6 equal to 0. Now it is a standard equation. Now you can solve it. So 2x is equal to 6, x is equal to 6 by 2 and x is equal to 3. So this is how we can solve any given equation which is not in a standard form. We have to reduce it in a standard form and then solve the equation by any of the methods. We have solved it by transpose method. Now let us take one more example. We have an equation here, 3x plus 4 upon 4x plus 2, 3x plus 7 upon 4x plus 5. Now this is not in a standard form. Whenever we have only one term on the left hand side, another term on the right hand side, then we can go for what we call multiplying we can cross multiply them. So let us cross multiply. That is 3x plus 4 into 4x plus 5, and 3x plus 7 into 4x plus 2. Now we can multiply these two by applying distributive property. We have 3x into 4x, that is 12x square. Then we have 4 into 4, 16x. 3x into 5 is 15x, and we have 3x into then 4 into 5 is 20. So that is how we open it. Again I'll repeat, 3x into 4x is 12x square, plus 4 into 4x is plus 16x, then 3x into plus 5 becomes 15x, and plus 4 into plus 5 becomes plus 20. So also here 3x into 4x is 12x square, and plus 7 into plus 2 is plus 28x, and plus 7 into 2 is 14, and we can just open this and get the simplified terms here. Now 12x square cancels because LHS RHS the same term is there, we can cancel it. Then we have 31x, then minus 34x, that means 34x is brought to the left here, we have got minus 34x. Then we have 14, 20 can be moved to the right, that is minus 20, again by transpose method. Now simplified, that is 31x minus 34x is minus 3x, and that is equal to minus 6, x is equal to 6 by 3, x is equal to 2. So this is how we go for what you call finding or solving the equation, converting them into standard form. Now remember the method here, eliminate the denominator by multiplying each term of the equation by LCM of the denominators. Simplify and get standard form of the equation. This is a very important step here. First step is eliminate the denominator and check how many denominators are there, multiply them, eliminate the denominators, and simplify and get a standard form as we have got it here. Now if possible, cross multiply and eliminate the denominators. Again that is also true here, we can cross multiply and eliminate the denominators, simplify and solve for value of x, which is the solution. That is the method. Now algebraic equation. An equation of algebraic expressions is an algebraic equation. An algebraic equation is true for a particular value of variables. It means a particular value of variables satisfy the equation or makes LHS is equal to RHS. Now let us understand this. Now we have algebraic equation here, x plus y equal to 7. It is a linear equation in two variables. Now if I put x is equal to 3 and y is equal to 4, 3 plus 4 is equal to 7, 7 is equal to 7, LHS is equal to RHS. That means when x is equal to 3 and y is equal to 4, we get LHS is equal to HS, or the value of x is equal to 3 and y is equal to 4 satisfies the equation. Now here also if you see, x plus 2 is equal to 5. Now if I put x is equal to 3, it becomes 3 plus 2 is equal to 5, 5 is equal to 5, LHS is equal to RHS. That means this equation, which is a linear equation in one variable, is satisfied by a value of x which is 3. Now very interestingly, both these equations are satisfied for particular values of x and y, and therefore they are simply algebraic equations. Therefore remember, particular values of x and y satisfy the equation or make LHS equal to RHS, and therefore they are simply algebraic equations. So algebraic equations are satisfied by particular value of the variables. Remember that.